API Conference, Elevating API Literacy.
Good morning, everyone. Um, yeah, I hope you are happy to be here, just like I am. Seeing wonderful faces. A lot of people I have not seen in a while. Work on different places. You live, and sometimes you don't see each other for a while. Yeah, so today I'm going to be uh, presenting building resilient systems with idempotency APIs. Um, so there are two concepts here. The idea is that we want to be able to have a system that even if anything happens, the system is able to, come back up and is able to recover. So that's the idea of resilience. We want to have a system in which even if something goes down, like, a lot of things can happen, an error happen, a server goes down. By the time it comes back up, all the requests, everything that was happening before should just go back to the way it was. So that's the idea. So that's what we're trying to achieve with this concept. And what we're going to be using for that is idempotency. So the idea of idempotency is that if you make like several requests to the server, or using an API, you are going to get the same response as long as you have not changed the request. So you are still making the same request. So what this does is it helps you to make your system, like I said, resilient. Then it also makes your system consistent. So if it happens that, I think we've all experienced it, you're shopping online, uh, and maybe while you're trying to add to cart or something, or trying to make payments, there's an error, and then you you didn't get success, of course. You didn't get 200K. So you try again. And when you try again, you just realize that you check your account, you'll be debited twice. So that's what happens when you have an API that is not idempotent, that doesn't have that capability. So what happens is, if there's a failure, the system has no way of knowing that or handling that. So you have cases where people do like multiple transactions of the same request. So that's uh, basically what idempotency is. So make sure that you are making the request, but uh, you are getting the same response. So yeah, just explaining that. So what is a idempotent API? So it ensures that repeated requests produce the same results, as I've said. So this is an example, just this structure, like uh, used to explain that. So the first request comes in, even if there is no response to the user, whether it's the client, or maybe you have like a microservice architecture, you have services talking to each other. As long as the client doesn't receive a response, you are still able to handle it in such a way that even when a request comes in with the same payload, you are able to just keep that. So it's now up to you to decide whether you want to return to the clients that duplicate requests. You can also decide to return a response. So what it means is that you will have handled it in the back end in such a way that when a request comes in, you handle it the first time. So if the same request comes again, you skip it. You don't let it eat your back end, your database anymore. So you either decide to tell the client that, oh, you sent this request before, it's already handled, it's duplicate, or you might just send the response so that the person just gets the response and they think it just went through, whereas it actually did the first time. So that's the idea. These are like real world applications. So this is why this is very important. We have payment processing, which I've given an example. You don't want to like be debited twice for doing the same thing. So we all know how that is, how to even charge that, or, try to get that from the bank. I'm sure most of us have suffered that. You can't even get your money back. So that's one of the ways where idempotency could help. And other processing, I think I've also made that example as well. You're trying to shop online, you add to carts, maybe when it's time to pay or something, or even when you're adding to carts, if there's an issue and you didn't get a response. So idempotency ensures that you don't keep adding the same thing. Then distributed systems, like I said the other time as well. So when it comes to resiliency within your system, so apart from just communication within like the front end and back end, so even inside your system, if you have a microservice and you're using like API communication, for example, you can have idempotency inside in such a way that if a communication there's a communication between one service to another, and the service that is being called goes down. So if the client now, which is like the other service, makes that call again, the other service already has that the potential, so it's able to handle it. So it won't be like you are sending the same request and you are getting like two separate responses. So you are going to get the same response. So it helps you to, like I said, your system will be resilient. So that's that. So I think in the next slide, I'm going to like explain how you can go about like making your system like have that idempotent behavior. Can we make this system idempotent, please? I don't know. Okay, so the first thing to do is to assign a unique request ID. So basically, there are different ways to do this. You can either allow your server to generate the idempotency key and send it to the front end. So the front end starts using it for all requests, all subsequent requests. So that's, I think when the idea of idempotency came into place for APIs, that was like the common way of doing it. But the issue with that is if there's a break in that communication, then the whole idempotency is defeated. So the way I prefer to do it is to make sure the client sends is the one that decides which unique request to send. And also, I prefer to use parts of the request that if they change, then it means the payload is different. So for example, you are sending a payload to add to cards, for example. So you can put amount, parts of the items, maybe all of the items, just concatenate them, and that's the idempotency key for that request. So what it means is that if anything changes, then that means that's a different request. But if it's still coming that way, you know that it's still the same request. So that's how I like to do it. So that's assigning a unique request. So whether you are doing it microservice, to microservice or your front end, so you just define like some standard. Okay, this payload plus this payload plus this payload, that's your key. Okay, yeah, so the second is the client includes the request. So, like I said, since you are making use of the payload, like turn on the payload, join them together, so it means it's easy for the front end, or let me just call it client, to keep using the same thing. So, yeah, that's the idea for that. Now we go to the deep part. I hope you all can see the screen. So just going through like I said, how to set it up. So I also prefer to use Redis as the part that handles the idempotency, like saving the idempotency and all that. You can actually use the database. One thing that I love about programming is that it's not monolithic. It's not one way. You can do it however you want. But I prefer Redis because it's faster. So yeah, so the first step is to set up your Redis instance. which is what I'm doing here. So the next step after doing that is to, yeah, I'm sorry, I tried to fit everything in the screen. So this is my Idempotency service. So what the service does is to use the Resi setup that we have to actually manage how the idempotency happen. So we have the check and store key. So that checks ready whether the key exists, and it also stores the key. And another thing that is very important here, which you have to note, is the TTL. So you have to determine how long you want the information to be saved, because that's of course going to affect the whole flow of the idempotency. So if, for example, you want it to like be saved for 1 hour, for a couple of minutes, so it's up to you. I think from the experience in the banking sector, I think I use a bank that I believe they're using something like this, Sterling Bank. If you send the same amount to the same person within the hour, so they are going to ask you that you sent money to this person and you want to do it again. So that's how you do that. So you can decide the time that you want to use. So for the get response, like I said, I'm also doing it in such a way that response is saved, so that even if you can make it the same request, I'm just getting it from Redis and giving it to you. Nothing is in the DB. So that's what get response does. Then store response, they can't fit everything in, but basically I'll just use Redis to store the response, and then remove key as well. So if you want to remove the key, so that's possible as well. So the next step is actually like where we have the middleware that handles, the idempotency. Yeah. So inside the middleware, we are checking for the idempotency key. In this case, it's inside the header. So we are checking if an idempotency key is present. And if it's not present, we are showing an error because it's required. We want our API to have that idempotency, capability. So the next thing is to catch the response. So we try to get a response. So if a response, that means it's already cast. You've already made the request. We've saved it. So that's the next thing. We just throw it to you, take it, and it's 200 as you see, because we're not creating anything. So it's not 201. So it's not hitting the DB at all. Then the next step is if we don't have anything in the system, then we check if the idempotency key is unique. If the idempotency key is unique, then we store the key with we store the key and from what we have in the service, if you remember, is going to put the status as processing. So yeah. Then after that, so if it's not unique, then we'll say like duplicate request. So that's how we handle that. The next thing is showing how we actually use that. So this is how we use it on the route. So basically just putting the middleware, on the route that wants to use that. So I'm kind of using an example of like some of our products in Fincra, like our payout. So just using it as an example. So if you're doing like multiple payouts with the same request, maybe there's an issue, you didn't get the response. Yeah, so that's the kind of behavior. So this just the setup. And so inside the controller as well, that's where we save the response. So what it means is that when we get the initial request and everything is fine, we don't add that. It's not a duplicate key. So what we do is that after we do the normal thing we're supposed to do in the controller, we now save that. So we save it, as you can see, store response. So the response that we get, to save it so that when you make another request using the same idempotency key, we just show you the response that has been saved. We don't need the DB, so there's no double debit. We are saving you all those stress. So that's what's going on here. And I also added a request date so that uh, we can actually see the difference when I show you like the different, like the payload for the first request and the payload for the second request. Okay. I don't know if this is clear for all to see, but this is the initial request. So this is showing true one created, and if you look at there is a request date as well, which is I believe 0059. So that's the request date for the first request. So now we're going to use, and you can also see the idempotency key that I'm using. You can see that it's part of the payload. So I'm using the business ID with the amount and yeah, I believe the name as well. So that with the beneficiary name. So that makes it easy, because if any of those change, then you are sending money to somebody different. But if you are sending money to the same person, the same amount, then yeah, you are still making the same request. So we're looking at the second request. So the second request, as you can see, the status is 200 OK. So instead of 201, because we're not actually creating, we're just getting it from Redis and showing it to you. And also, if you look at the request data, is one, so it's different. The date is different from the other one, because they're actually like done in different times. So that's just a way for me to kind of showcase that yeah, even though you are getting the same response, you actually like made the request at different times. Uh, okay, yeah. So still using the same idempotency key as I said. Um, so yeah, these are like some downsides. Like I believe like everything has a balance. So not everything is just has advantages. So you have to have disadvantages as well. So some of it is that like you can add some complexity, to the system if not handled very well. How you are managing the idempotency. So that's one of it. Then it can also increase latency, as I believe we've noticed that every time every time we make a call, we are checking Redis, and if it's a call that still has to go to the database, that means basically it's two database, make two database calls. So, and it's possible that inside that controller we can have a lot of other calls as well. So it adds, a little bit of latency. Um, then also it's not suitable for all use cases. You can't, because oh, you like how this thing is working and all that. You can't just say all of my APIs, I will just put idempotency there. So it doesn't work for all APIs. It's for specific APIs, which is why we went through like word applications the other time. If you're working on an API that has to do with order processing, payment, all those kind of things, you can make it idempotent. Then also the microservices inside your system, there are certain APIs as well that key APIs, maybe a call to the wallet, for example, to debit, to credit, all those kind of things. You can make it idempotent. So overall, like I said, even though it has some downsides, I think the advantages still outweighs like the disadvantages, because it helps you to make sure like your system is resilient. Like I said, that's from experience, by the way. Like the microservice architecture that we have in Shrinkra, if any of the services go down, we are still able to come up and still handle requests that that have been made to that service. So basically, the advantages is more than the downsides. Uh, that's it. Thank you very much.
API Conference, Elevating API Literacy.